Now that we already talked about the abstraction, let's move to the second object-oriented design principle, and that is encapsulation. Let's see what is encapsulation, and after the theory part we will write live code for the encapsulation and Java as well. Encapsulation means containing data and behaviors in a single unit, like a capsule. You have identified the objects, and now about each objects you have to enclose all the data and behaviors inside a single class, and that is what we called encapsulation. And then some parts are accessible and some are hidden. For example, if you are developing a system for library management system, and there you identified an object for student, so student would be having data like name, reg number, date of birth, and date of joining. So these are what we call data, are attributes of the object, and the behaviors would be like issuing book, returning book, and some other behaviors can be added as well. And then we can keep some of the behaviors and data private, and some of them can be kept as public as well, that can be accessed from anywhere in the program. So later on we will see that with extensive examples, so you would understand it deeply. It bundles attributes and functions into a class, exposes only selected part through interfaces. Right, you want to change the data, so you can't directly change it. You have to use a controlled way for that. For example, if you want to move from one country to another country, it's not like that you can't move. Yes, you can move, but you have to adopt a particular controlled way. For example, you need to have a passport, you need to have a visa for that country, only then you can move from one country to another country. So same goes here. You want to see or access some data, so you can directly access it. You can access it through a controlled way. Restrict access to sensitive details, and for example, you have a account in bank, so you can directly change your balance. If you were able to change your balance, you would have made it in billions and millions, so you would be one of the richest person in the world. But unfortunately it's not like that. You can't make changes to your balance directly. Yes, you can change your balance through controlled way, like depositing money in your account, and that way you can definitely change it, but that is a controlled way, that is not direct way. Ensures each object has its own data and behaviors, so there are no mix of the data and behaviors of different objects. If you have identified all the potential objects, so each object must have its own behaviors and its own data, making programming easier and keeping data and related to code together. So for example, if their change comes in a particular object, so all other objects are not affected. It builds on abstraction by not just identifying essentials but also packaging them in one place. For an e-commerce store, for example, you have identified the payment subsystem, and you encapsulated that system in its own components. Now if you want to add more payment method, or you want to make it secure or improve the performance, so other subsystems would not be affected, and that is the main goal of encapsulation. Let's talk more about encapsulation. By restricting direct access, it protects data integrity and sensitive information. This is very, very important, and sometimes it comes an interview question like why do we use encapsulation? So to protect the sensitive data or data integrity, something you can't change directly, so we need to use encapsulation for that. And earlier I gave you an example of changing your account balance. That is not directly allowed. Yes, you can change it through a controlled way, like depositing or withdrawing money, you can change your account balance, but you can directly change your balance. So that is what achieved through encapsulation, while allowing controlled changes. With black box thinking, classes hide their internal working. Think of a scenario where you want to withdraw money from the ATM machine. So there you insert your card and enter your PIN, and then you choose a particular type of transaction, and either you receive a cash or transfer money from one account to another. So there are different type of transaction which you can perform, but while entering the PIN, you do not see how the PIN is verified, and then after that you do not see how the ATM is connected with the bank, and how the data, the balance is updated in the database. So these are something which are kept hidden from the user. Only provide inputs and outputs through methods. You can only enter the PIN or choose a particular transaction type. You cannot see the internal working of the ATM, reducing complexity, and that is what we aim for. We want to reduce complexity of our system, so we can achieve that by encapsulation. This makes software more modular, reusable, secure, and easier to maintain or modify without affecting other parts of the system. So encapsulation protects important data, hide complexity using black box thinking, and makes software easier to modify, reuse, and secure without affecting other parts of the system. Now let's take a look at an example of encapsulation. I have added a real world example from a real life, which you can relate to encapsulation. You can see the cat. This is just a simple tie for cat, and if you touch the back side or the back of this cat, it would start purring. And similarly, if you touch the belly of this cat, so it would sound like meow. But what you see is the system is hidden, the implementation is hidden from you. You just know that these two features exist in this cat tie. Touching on the back would starting purring, and touching on the belly would make the cat to start meow meow meow. So that is what we call encapsulation, and that is how encapsulation works. Thank you so much for watching this. Before you go, please don't forget to subscribe to my YouTube channel and turn on the notification bell so you never miss any of my upcoming videos. I regularly share valuable lessons, practical tips, and step-by-step tutorials to help you improve and grow. And if you are serious about mastering software design and architecture and want a complete structured learning experience, so I have created a full course that includes detailed lessons, assignments, quizzes, and downloadable workbooks to help you practice and apply what you learn. So if that sounds helpful, just check the link in the description below and enroll in the course today. I would love to see you inside and support you on your learning journey.